Now let's begin looking at our second set of tools, the machine learning tools. So under this, we have 8 tools to verify: TensorFlow, Keras, Scikit-learn, Theano, PyTorch, H2O.ai, DL4j, and XGBoost. So let's begin our journey with TensorFlow. TensorFlow is an end-to-end machine learning platform. It prepares and loads data for successful machine learning outcomes. The data can be the most important factor in the success of machine learning endeavors, and TensorFlow offers multiple data tools to help us consolidate, clean, pre-processed data at scale. Standard datasets for training and validation are available. Highly scalable data pipelines for loading data. Pre-processing layers for common input transformations are available with TensorFlow. Tools to validate and transform large data sets are also available with the TensorFlow. Additionally, responsible AI tools help one to uncover and eliminate bias in the data to produce fair, ethical outcomes from the models. The TensorFlow platform helps one implement best practices for data automation, model tracking, performance monitoring, and model retraining. Using production level tools to automate and track model training over the lifetime of a product, service, or business process is critical to success. TensorFlow is a Python-friendly open source library for numerical computation that makes machine learning and developing neural networks faster and easier. TensorFlow allows developers to create data flow graphs, structures that describe how data moves through a graph or a series of processing nodes. Each node in this graph represents a mathematical operation, and each connection in the edge between the nodes is a multi-dimensional data array or a tensor. So the node in the graph represents mathematical operation, whereas the edge or the connection between the nodes is a multi-dimensional data array or a tensor. So that's how we can represent. So the data can be represented as a tensor. Tensor is general multi-dimensional data. So zero dimension data, a tensor is a scalar. One dimension tensor is a vector. Two dimension tensor is a matrix, and that way n dimensional tensor is a data with n attributes, and that's the first part of the TensorFlow, tensor. Whereas the flow represents the data flowing through the various nodes, and each node here represents the mathematical operation. So the right side of the slide talks about the flow. So the data first gets into additional block, and then gets into matrix multiplication block, and then finally result is made available. So the advantage of working with this type of environment is when one data is fed in, it gets into the addition mode, and in the next step the same data gets into matrix multiplication mode, the next step result is available. So if this is being done for multiple datas, then we can visualize that when one data's result is available, then its next data is under a matrix multiplication process, and its next data on the pipeline is in addition, and the next one is getting ready to enter this flow. So this way, what happens is due to this pipeline effect, we see that multiple actions take place simultaneously, different places for different data. So that makes the overall performance more efficient in terms of size as well as the time. So TensorFlow, we can build and fine tune the models with the TensorFlow ecosystem. So explore an entire ecosystem built on the core framework that streamlines model construction, training, and export. TensorFlow supports distributed training, immediate model iteration, and easy debugging with errors and such similar tools. Tools like model analysis and TensorBoard help one to track development and improvement through the model's life cycle. TensorFlow helps in deploying models on device, in the browser, on premises, or in the cloud. TensorFlow provides robust capabilities to deploy the model on any environment, maybe server, edge devices, browsers, mobile, microcontrollers, CPUs, GPUs, FPGAs, and many more. TensorFlow serving can run the machine learning models at production scale on the most advanced processors in the world, including Google's custom tensor processing units, TPUs, which are very famous when it comes to working with multidimensional data, especially image and video processing. TPUs contribute much and make the process very faster because it's being done on the Google cloud, and parallelly multiple TPUs may be working together and make the thing very much faster. TensorFlow allows us to implement machine learning operations on production machine ML. TensorFlow platform helps one to implement best practices for data automation, model tracking, performance monitoring, and model retraining. Using production level tools to automate and track model training over the lifetime of a product, service, business process is critical to the success of the product. TFX provides software frameworks and tooling for full MLOps deployments and detecting issues as data and models evolve over time. Yeah, that's a overall summary how TensorFlow can be used. So the users can use the JetSkins will use, and that is in continuous integration with GitHub. GitHub provides the TensorFlow and the Python, C++, NVIDIA, other dependencies require TensorFlow. TensorFlow uses TensorBoard for visualization and various platforms for execution, and TensorFlow contributes to stakeholder community like developers, integrators, researchers, companies, This whole thing is under the support of Google. Yeah, there is a Android or a mobile version, that's a TensorFlow Lite. Here we train a model, then convert the model, optimize the model, and finally deploy the model at the edge. So for Android, it can be Android, iOS, Linux-based devices like Raspberry Pi, other microcontrollers, and finally make the interfaces to edge. So the overall TensorFlow, what all activities we can do with that? So we can use the TensorFlow for training as well as for deployment. Under training, we have a TensorFlow Hub, which provides us keras and pre-made estimators, which will help us in reading, pre-processing the data. Then distribution strategy is taken care by this TensorFlow, and the process activity is distributed among CPU, GPU, and TPU, depending on whatever is available whenever anything is available. So CPU is the simplest central processing unit. It's a very slower one. GPU is the next one, graphic processing unit. So it's very much faster compared to CPU, but TPU is the fastest one. So depending on the situation, we are working on the cloud, then sometimes some TPUs are available, sometimes GPUs are available. And when none of them are available, then we have to be happy with the CPUs. So this whole distribution strategy is taken care by the TensorFlow, and from time to time, depending on the availability of GPUs and TPUs, they will be allotted. And finally, model is created and that model is saved. And the saved model can be deployed using the TensorFlow serving onto the cloud or on premises. Using TensorFlow Lite, it is deployed on Android, iOS, Raspberry Pi devices. Using TensorFlow.js, it is deployed on the browsers and node servers, and other language bindings for C, Java, Go, C hash, Rust, R, and all are also available. So that's some idea about what TensorFlow can do. So many more details to come. So please keep watching.